just going to show you this one as an example. As you can tell, this is a Dwayne original drawing. Now, you can pause this and look at it all you want. You can, even, I'm not even going to give you a printed copy of it because it's not that good. But here's my point. Couldn't you make a diagram for the carbohydrates, make another one for the proteins, make another one for the lipids, where you itemize each enzyme and where it's working and what it's doing? Right? I think. I hope. Copying mine, printing mine, does not help you do anything. Making one on your own helps you get a better mastery over these enzymes and where they function. So look at how I created this one. Being the chemistry lover that I am, I wrote out the hydrolysis like a little chemical equation here. See that? With the enzyme written above the arrow. This is sort of the traditional way that we do this. And I think I was making the enzymes green. So I like colors. So there's the enzyme. Is there an enzyme in the oral cavity that works on carbohydrates? Yes. It's called salivary amylase. Comes from your salivary glands. What does it do? It digests some carbohydrates or polysaccharides into what? Smaller polysaccharides and some disaccharides. That's the job of salivary amylase. And I know you can all do this, but I want to really emphasize, I guess I better not pick that color because I already used it. Let's go with the green here. I really want to focus your attention on this word some that I wrote right here. Some carbohydrates. Some carbohydrates. This is true for all of our enzymes that do hydrolysis, breaking things down for us. See this piece of paper that I have some lecture notes written on? I'm not going to, so don't get excited. Could I eat it? Certainly. I assume it would taste pretty bad, but couldn't I eat this? Could I chemically digest it? No. This material is cellulose, a sugar, a polysaccharide. But guess what? I have exactly 0 hydrolase enzymes that digest cellulose. You know, we call this in the nutrition game, this is called dietary fiber, everybody. It passes through my entire GI tract chemically unchanged. I can't digest plant cell walls because I don't have an enzyme to digest it. I do not have a hydrolase enzyme that works on cellulose, so I can't do anything to cellulose. Some polysaccharides, I have a digestive enzyme that'll work on salivary amylase. So my point is this, if you don't have a hydrolase enzyme for it, you can't digest it. Got to have the enzyme for it. So my lipases digest some lipids, my amylases digest some polysaccharides like that. If you don't have an enzyme, you can't do any chemical digestion, you can't do hydrolysis. So sort of like in math, do you know how in math they sometimes give you an equation and they don't show you the coefficient? You know, let's say you had this. He's thinking about math. So you have x plus x equals 2x. They don't even bother to write the coefficient here. It's a 1. They call that in math the understood 1. So in digestion, what we have is the understood sum. When we start out with the chemical digestion of these molecules, I'm just showing you this one as an example. So what chemical digestion to carbohydrates happens in my esophagus? Nothing at all. No digestive enzymes released in my esophagus. In my stomach, no hydrolase enzymes that work on carbohydrates in my stomach either. You thought your stomach was so important. No, the small intestine's where all the action is. We know that. Keep going down, and then I get to my small intestine, and guess what I have here? Another amylase enzyme, pancreatic amylase. I'll keep my highlighting going. There's the enzyme. Here's the substrate, like starch or glycogen. And it'll break this down into what products? Disaccharides, maybe maltose, isomaltose. Then, on the brushy border of my small intestine, I've got more enzymes that are listed in my table. Enzymes are green. Sucrase, we already saw that one. Maltase, isomaltase, and lactase that break down the substrates, sucrose, maltose, isomaltose, and lactose, those sugars, disaccharides, into what products? Glucose and fructose, glucose and glucose, little g for glucose, by the way, people, glucose and glucose and galactose. These are the monosaccharides, the monomers that I could then absorb. So I've gone up in my mouth from complex polysaccharides all the way down in my small intestine to monosaccharides, which I could then absorb. I hope everybody sees this. I encourage you to make a similar chart for proteins, a similar chart for lipids, and make your own chart for carbohydrates. Don't just copy mine. That's not really that helpful, because you have to get fairly good at describing these things and where they get chemically broken down from polymers to monomers. See how that works? And again, I can absorb monomers. I can absorb monomers.